So we're going to continue right along. It says, again, same instructions. So let's start with the vertical asymptotes. Vertical asymptotes we find by setting the denominator equal to 0. So we'd say 2x squared minus 8 equals 0. Again, what I'm going to do this time is I can divide everything by 2. It's kind of like a GCF, but since I have a 0 on the other side, I can just divide it out of the equation. So if you divide everything by 2, you're left with x squared minus 8 equals 0. Not 8, I'm sorry. 2x squared minus 4 equals 0. Again, this is a difference of squares, just like the last problem. So I'd have x plus 2, x minus 2 equals 0, which means I'm going to have an x-intercept at negative 2 and another one at 2. Now let's go on to horizontal asymptotes. We look at this problem. The powers are the same. So this one you'd say eats DC. Exponents are the same, so we divide the coefficients. So I'm going to look at these values here. And so it'll be y equals 1 divided by 2. Is that equation? This kind of gets messy. Let me do it like that. So you can see it's 1 over 2. And then finally, intercepts. It looks like this one might have multiple intercepts. We take the top and we say that x squared minus x minus 12 equals 0. Now this on the left I can factor. So I'm looking for factors of negative 12 that add up to negative 1. That would be negative 4 and positive 3, I believe. Yep, that works. Since that a is 1, I'm just going to put in x minus 4 and x plus 3 equals 0. That means I have an intercept at x equals 4 and another one when x equals negative 3. Let's look at our graph. So here I have an intercept, and this is at negative 1, 2, 3. I should have another one at 1, 2, 3, 4, which I do. This is my horizontal asymptote at y equals 1/2, and then these are my vertical asymptotes at x equals negative 2 and x equals positive 2. My domain, it appears, is that x cannot equal negative 2 or positive 2. Those vertical asymptotes. So it's all reals other than the asymptotes for most of these examples we've seen. Here's one for you to try.